Okay, this is just a video on your results, analysing results. Okay, so we've got replication, randomization, and control. So you actually need to talk about these sort of things in your discussion. So replication, why did you use 3 pots? Randomization, did you do it in any order? No, you didn't. Okay, the variables. The independent variable was the fertilizer. The dependent variable is what you measure, which is the weight. Okay, analysing data, variance, standard deviation. This is how closely the values cluster around the mean. Okay, and the standard variation is the square of the root of variance. Okay, so this is how you work out the standard deviation. Let's just go a little bit further on. Whoops. Here we go. This is a coefficient of variation. This is the absolute measure of dispersion. The smaller the value, the greater the reliance can be placed on the results. All right, you'll see what I mean by a minute. Probability and normal distribution. As the sample from the population becomes larger, the sample mean approaches the population mean. So the trend of the bell-shaped curve is called the normal distribution. All right, so this is a normal distribution. This is a bell-shaped curve. Okay, so the more that you've got it closer to here, the more it's going to be the right sort of accurate. It's going to be accurate. Okay, significance of an experimental result is the probability at a chosen significance level. The significance is usually 5%, which means the same result will occur 95% of the time. Comparing standard errors. Right, we've got on our spreadsheet here, we've got comparing our standard errors, and you'll just notice down here it's actually standard deviation 2. Okay, and we go to sheet 3 because I've set it up with treatment 1, 2, 3, 4. Okay, so this is the number of plants you've got, the weight or the total weight, and then weight per plant. Now this is how I did it. I worked it out doing it this way, but it's not necessary that you actually do it this way. However, this is how it works. In a Excel spreadsheet, you can put in formulas. All right, so this is average B2 to B5, median, mode, standard deviation. That's the formula for the standard deviation. But what we've done is standard deviation. See, that's there, and it's 2, 3, 4. So it actually works it out automatically for you. Coefficient of variation. There's actually a little thing there. Formula there. All right, confidence of the population using normal distribution. Right, we've already talked about that, and this one. Okay. Standard error. Again, that's the formula. It's a little bit more complicated, but if you can follow it, it'll be great. Twice the standard error is just that 1 times 2. And then if the difference between the two means is more than twice the standard error, the difference in the results is significant. So what you're trying to do is prove that the results are significant between one type of treatment to the other. So you have to actually do all the different treatments and compare them. All right. So on this sheet here, it gives you a little idea of that as well, but then I'll put it into the PowerPoint so you can actually look at it as well. Okay, so there's that one, and so on. Okay, we're going to leave it at that. Thank you.